Good afternoon, class. Good afternoon. Thank you. You can sit down. All right, then before we go on to the next subtopic, we'll have to look at the exercise on similar figures and similar solids that you were given for homework. Question 4, question 5, and question 6. Question 4. Kiapin, would you like to give us your answer, please, to question 4?
(990 square centimeter).
990
90.
square centimeters. Is there anyone with another answer apart from 990? Anyone? Nobody has another answer from 990. Jake?
29,700.
29,700 square centimeters. Is there any other answer apart from those two? All right, how many people have 990 square centimeters? Put your hands up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. How many people have 29,700? Like, put your hand up as if you are really happy that you've got that answer. Okay. See, sometimes the reason why you get things wrong is because you're not very confident with yourself. You are scared to make mistakes. That's how you learn. Okay, we'll see what the answer is. Now, the scale is 1:30. That's the scale. Says an accurate model is made of a van using a scale of 1:30. If the area of the rear doors on the model is 33 square centimeters. Now, if a scale is to be written this way, it's usually the scale of the length. It's the linear scale, which means you will have to actually square it to get the scale of the area. Okay, so this would be the linear scale, or what I call the length scale, which means 1:900 is the scale for the area. So you're supposed to use this one. 1:900 is equal to 33 square centimeters over x. Okay, so 1/900 equals 33 on x. You all agree? Okay, another thing, please. If you have this 1:30, don't make it equal to 1:900, because this is the ratio of the length, this is the linear scale, this one will be the ratio of their areas. Because when you square them, then they are equal, but like that, they are not. So make sure you write it down correctly. Okay, so all you have to do is just multiply 900 by 33. And I think you get 29,700. Okay, those of you who got, excuse me, those of you who got 990, you used 1:30. Okay, 29,700 you get when you use 1:900. All right, the next one. Number 5. You are told that if the full-size van in question 4 has a fuel tank of capacity 135 liters, which is its volume, the volume of the fuel tank, what would be the capacity of the model's fuel tank in cubic centimeters? Gabriel. What's your answer for that one?
Cubic centimeters.
How
Five.
many? 5. Okay, it should be in centimeters.
Cubic centimeters.
Okay, centimeters cubed. Let's see if there's someone else who's got another answer. Any other answers? Raylene, what's your answer?
$4,500 cubic centimeters.
4,500 cubic centimeters. Any more answers? Anyone with a different one? Boromio? You've got the top one. Patrick? You've got 4,500. Anyone else who's got a different answer from these two? No? Vui? What's your answer?
$3,645,000,000.
3,600,000. 3 billion. Okay. 645.
45 million.
1, 2, 3. Another 1, 2, 3. Is that it? Cubic centimeters. Any more? So you have either one of these three. Yeah? All right, the full-size van in question 4 has a fuel tank of capacity 135 liters. What would be the capacity of the model's fuel tank? In cubic centimeters. Okay, cubic centimeters is a volume, it's a measure of the volume. So as liters. Okay, it's the amount of space in the fuel tank. You are told that 1 liter is equal to 1,000 cubic centimeters, which means the fuel tank has a capacity of 135,000 cubic centimeters. Now, if it is talking about the volume, then if the linear scale is 1:30, then the scale for the volume will have to be 1 cubed is to 30 cubed, which is 1:, what's 30 cubed? 27,000. Okay, so 1:27,000. The real tank has a fuel capacity of 135 liters. We have to find the capacity of the model tank. So that's equal to X is to 135,000. So X to 135,000. So 1/27,000 is equal to X over 135,000. So what are you actually supposed to do here to get X? Divide 135,000 by 27,000. What's 135 divided 135 divided by 27,000? 5. Exactly? Okay, 5 cubic centimeters. So 5 cubic centimeters is correct. All right, the last question. Given that AB is 7 centimeters and that the area of the triangle ADE is 4/9 of the area of triangle ABC, calculate the length of AD. All right, let's get some answers again. Taumaku, this time your turn. What's your answer to number 6? The length of AD?
AD equals 4.7 centimeters.
4.7? Okay. Any other answers? If you disagree with Tamaku's answer? All of you have 4.7? Everyone? I don't believe it. Okay, let's see if you are correct. Given that the area, the length of, there are two triangles that I see in the triangle given. One is a small one, and that's A, D, E. One is a big one, A, B, C. You are told that A, B is 7 centimeters. And the area of ADE to ABC is 4:9. So 4:9 is the ratio of the areas of ADE and ABC, which means the ratio of their lengths is going to be 2:3, which is the square root of 4 to the square root of 9. You cannot use 4 nines to find the length. So we are looking for AD, which is x. So you are going to say 2:3 is equal to x is to 7. So 2 on 3 equals x is to 7. 14, right? X is equal to 14 on 3, which is 4.66 recurring, which is 4.721 decimal place. Okay, very good. Now the topic for today, which is also the last topic on ratio and proportion. All right, the topic is on using ratio and proportion on scales of maps. Right, I know that you've done this in social science when you were in grade 10, so this should not be difficult to do. All right, I've got some notes on the monitor. If a scale on a map is 1:10,000, that means that it means that 1 centimeter on the map represents 10,000 centimeters on the ground. Because for a scale to be written in ratio form, it has to be in the same unit, or otherwise centimeters is the one that is used. 1 centimeter on the map represents 10,000 centimeters on the ground, and 10,000 centimeters happens to be 100 meters as well. So 1 centimeter on the map represents 100 meters on the ground. All right, there's another note there. When areas are to be compared, it is necessary to use the square of the scale of the map, because the scale is actually the scale of the distance, not the area. So you have to square it just like what we've been doing, to use it to find the area, to calculate for area. Okay, I've got an example there. The scale on a map is 1:50,000. What distance does 3 centimeters on the map represent? So first, 1 centimeter is equal to 500 meters. What does 3 centimeters represent? All you have to do is multiply 3 by 500 and you get 1,500, which is the same as 1.5 kilometers. Okay, that one is very easy. So we'll go on to the next example. The scale of a map is 1:20,000. What area does 3 square centimeters on the map represent? If the scale is 1:20,000, that is 1:200 meters. 1 centimeter is to 200 meters. So the scale of the area will be 1 square centimeter. To get from 1 centimeter to 1 square centimeter, I multiply by, I square that one and I get 1 by 1. That's how I got 1 square centimeter, which means you also have to square the other side. 200 times 200 is 40,000. So for every square centimeter on the map, it will represent 40,000 square meters on the ground. And then you are asked what area does 3 square centimeter represent? Just multiply 3 by 40,000 and I get 120,000 square meters, which is, how many hectares is that? 1.2? Okay, 1.2 hectares if you want. Huh? 12? Oh yeah. 12 or 1.2? 12. Okay, you do questions 1, 2, and 3. It should take you 1 minute for each. Right, number 1. The scale of a map is 1 centimeter equals 5 kilometers. Express this scale as a ratio. Kyle? One is to, did you say 5,000? Okay, express it as a ratio. The units must be in the same, the units must be the same for you to be able to express it as a ratio. Is 1 is to 5,000 correct then?
No.
All right, so what do you think the answer is?
1 is to 500,000.
1 is to 500,000. Okay, 1 is to 500,000 is correct. Okay, yeah, well, it has to be in the same units. In maths, you cannot write a scale like this if this is in centimeter and this is in meters. It's not allowed. Maybe in geography you can. In maths you don't. So if this is 1 is to 500,000, then it will have to be in centimeters, which means 1 centimeter equals 500 centimeters. Like this, no, because this is in meters and this is centimeter. In maths, what we would do is write the equal sign, not like that. So the correct answer is 1 is to 500,000. If you say that, that means that's in centimeters. Number 2, Peter, the scale of a map is 1 centimeter equals 10 kilometers. What does 8 centimeter on the map represent?
Eight centimeters on the map represents 80 kilometers.
Okay, good. Number 3, Rita.
Um,
I'm sorry.
207,500.
200,
7,500
what? Meters, centimeters, kilometers,
centimeters. Centimeters.
centimeters, which is 2,075 meters, which is 2.075 kilometers. Right, next. 4 questions. All right, I'd like for people to come up and do the 4 questions on the board. So number 4, Velma. Number 5, Solomon. Number 6, Livingston. And number 7, Megan. Quick.
That means for this 1 centimeter, it will be 2 kilometers. You see, and this other 1 centimeter, it will be 2 kilometers. So which means it represents 4. So all you have to do is say, okay, if 1 centimeter is equal to 4 kilometers, how many centimeters will represent 1? That's all.
Next one, number 5, you can go. And 6 and 7, I think there's enough space for 4.
One more. How many square centimeters is 1 square kilometer?
Right, number 4 is correct, 5.6. Number 5, 80,000 square meters, correct, which is also 8 hectares. Am I right? Okay. Number 6, just a bit more. You are asked how many square centimeters will be equal to 1 square kilometer. X will be 0.25. Okay, like if you, to use ratio proportion 2, if you look at this, to go from 4 to 1, you divide by 4. All you have to do is divide by 1 by 4 and you get 0.25. So 0.25 square centimeters will be equal to 1 square kilometer. Number 7, 700 square kilometers. Where's my number 7? Yes. Okay. For homework, you will only do question 8. Right, 1 question only. You are doing very well in class, so you have only one question for homework. And please listen. Next topic is measurement. So you have 4 groups. This group is very small, so they are going to look at only one shape. The first lesson we are going to look at conversion of units. So if you're not really sure about the units, we'll do that again. And then each of you is going to select a a shape which you will explain to the class how to get the perimeter and the area of that shape. Okay, I am going to give, you won't really have a choice. I'll just give the shape to the class, to your group, and you have no choice but to go and do some research on it. The following day, the first group will present or will teach the class. All right, you'll have to go to your next class. The keyword to the pilot teacher is scales. So, good afternoon, class.